We are starting where we left off yesterday. Yesterday we were talking about transformations, and yesterday we talked about two main transformations. We talked about one transformation that was like this. What kind of transformation am I doing? Did we do this yesterday? A reflection, or this one is a vertical reflection, and then the other one, horizontal reflection. But we don't call it a vertical reflection, that's what it is, but we call it a reflection in the x-axis. Or it's this one, the reflection in the y-axis, right? And then we also had these kind where we talked about when there is a number in front of x squared. What operation is that? We talked about it yesterday.
Multiplication.
Multiplication. And when we are multiplying by a number in front, that does a what kind of transformation? Multiply, it's either a stretch or a shrink. So everybody give me an absolute value, give me an absolute value, and now I want you to say that we're going to do a stretch on your absolute value. Give me a stretch, give me a stretch. When you see those arms, what do you do if there's a stretch? Stretch! There we go. All right, check it out. Good job. All right, one more time, give me an absolute value. Now I want you to have a vertical shrink. All right, it doesn't go down. It just there's like less V. What would make the V go down? A reflection, right? A reflection in the x-axis. So just keep in mind, it only goes just a wider V. If it were flat, that would be just a complete equation, a different equation. And if it was facing down, that would be a reflection. All right, here we go. So what we did, we just did one example like this yesterday. I'm going to do a few more so you know what to do in your homework. We're going to look and we're going to see 1/2 x squared. And you're going to say, what is the parent function for 1/2 x squared? What family does that belong to? Quadratic family. And it is f of x equals x squared. So I'll write that here. That's our parent function. And then we go to the front page. If you don't know your ordered pairs, we're going to put in our parent function ordered pairs from the front page of our notes. And I have our parent function. And we're going to go over our graph and we're going to dash that on our graph. We're going to dash that parent function on our graph. So the parent function is the one that is dashed. It's not really the graph, it's just like our starting point. And then the equation, the actual equation is f of x equals 1/2 x squared. And you're going to say from the parent function x squared to the new function 1/2 x squared, what operation is taking place? Multiplication. Multiply by 1/2. So what we do is we take our y's, our y values, and we're going to multiply each of those by 1/2. So we'll get 2, we'll get 1/2, 0, 1/2, and 2. And it'll be a little bit easier to graph it accurately on your paper. Mine's like hard with a big fat marker, but you're going to graph the original x's and the new transformed y's. So -2, 2, -1, 1/2, 0, 0, 1, 1/2, and then 2, 2. And if you look at your graph and you feel like that's not enough information to really see what that graph looks like, if you feel like, I'm not sure, there's some halves in there, I'm not sure, we can always choose more points. So I'm just going to choose one more just to be sure. Since I'm multiplying by 1/2, let me pick something that would work out pretty easily. Maybe I'll plug in 4. I've already done 2. I don't want to plug in 3 and multiply by 1/2, so I'll plug in 4. If I plug in 4 for x and I square it, I'm going to get 16, and then I take 1/2 of that, I'm going to get 8. So 4, 8 is another point on there. So if you feel like you need more points, you can always add more points. Now, on your homework paper, the homework's set up exactly like this, except for I didn't write the word transformations on your homework paper. I put in the directions, right, what the transformation is. So I'll walk around later and see if you read the directions, but make sure we're writing the transformation also. What transformation is it from the parent function to the new function? We're multiplying by a half. David?
Vertical shrink.
Vertical shrink by factor of what?
Half.
Half. Perfect. So you guys are going to write vertical shrink by factor of 1/2. Do we have to write all of that? Yes. You know why I say vertical? It's spelled wrong all the time. So I say it weird, maybe you'll learn how to spell it. It's vertical. Okay? When you are ready to go on, turn the page so I know that right. Vertical. All right. So the next one is f of x equals 3x. What are we going to start with? We're going to start with our parent function. What family is 3x part of? Family is 3x. It's part of the linear family, right? So the linear parent function is f of x equals x. So we go and we copy down our linear parent function points. -2, -1, 0, 1, 2, and -2, -1, 0, 1, 2. That's where the x and the y are exactly the same. And I'm going to go ahead and graph that too. I need some straight edges. You can use a student ID, a driver's license, the side of your planner. Any of those things work as straight edges. If you're ever in a bind and you need a straight edge, this all works this way. Okay. So now we ask ourselves, to get from the parent function to the new function, what's happening? To get from the parent function to the new function? Multiply by 3. So that's what we're going to do. We're going to multiply everything by 3. Oh, not everything. Just the y values. We're going to keep the same x's. We're multiplying the y's by 3. So we get -6, -3, 0, 3, 6. And then we will graph the old x's with the new y's. And then you have to answer the question about what kind of transformation this was. So we're multiplying by 3. If it's a multiplication, it's either going to be a stretch or a shrink. Which one is this going to be? Shay, do you know what kind it's going to be? Stretch or shrink? Why is it stretch? You're right. It is multiplied, so that tells me it's a stretch or a shrink. How do we know it's a stretch? bigger than 1? If it's bigger than 1, it's going to be a stretch. If it's between what numbers, it'll be a shrink. Between 0 and 1, then it's going to be a shrink. So this number is bigger than 1, it's a stretch. And if you had your arms at y equals x, and you imagine stretching them, it's going to go higher. So this is a stretch. So we say vertical stretch by factor of 3. All right, the last graphing one. We've got f of x equals 0.2x. So first thing, or absolute value of x. We need to figure out what family this belongs to. What family this belongs to? Absolute value, right. Yeah, here. Hi. So it belongs to absolute value. We're going to go get the parent function for the absolute value points. We're completing our stuff. And then from there, we need to figure out what that 0.2 is doing next to that absolute value. What that 0.2 is doing next to that absolute value. Duncan, can you tell me what the 0.2 operation is?
Fraction.
It is a fraction, but what is it doing when it's next to? Is it add, subtract, multiply, divide?
Multiply.
Right, we're going to multiply. So what we're going to do is we're just going to take each of these y values, and I forgot to graph the original. I'll go do that in a second. We're going to multiply each of those by 0.2. I'm going to graph my original one over here real fast. Okay, so when I multiply each of these answers by 0.2, let's see if we remember how to multiply decimals. We multiply 2 times 2 first, 4, and then we write it as, do you remember how to multiply decimals? So 2 times, we just multiply the numbers, 2 times 2, and then you put the same amount of decimals that you multiplied over here. So if it's 4, and it has like 1 decimal, it's going to be 0.4. So you multiply 1 times 0.2, or 1 times anything is that same thing, so it's 0.2. And if we multiply 0 times 0.2, it is 0, good. And then 1 times 0.2 is still 0.2, and then 2 times 0.2 is 0.4. And then I go to graph those and I say, oh, it's kind of hard to graph. A little bit hard to graph. Why? I mean, how am I going to graph like 0.4 and 0.2? I'm going to attempt to do it. Don't graph those. Graphing -2 and then 0.4 is like here-ish. I mean, how accurate am I going to be? Not really accurate. But like I said when we did the 2 examples ago, you can add more numbers if you need to. So what would be a good number to have for x that I have to multiply by 0.2? It'll be a nice, easier number to graph. Does anyone have an idea, Timothy? Yeah, let's try 10. So if I do 10 and then I do the absolute value of it, it's 10. Multiply that 0.2, and I get 2. So 10, 2. And that also works for -10. That would be 10 and 0.2. So you can add more numbers in if you need to. to write down what our transformation is. We're multiplying, so it's going to be some sort of vertical stretch or shrink. Which one is this one going to be? How do we do now? You're still graphing. No. Carly, right? Natalie? Natalie, do you know? What kind of vertical what? Sorry. The question was, vertical what? Do you know? Shrink is right. Shrink is right. And that is because this number is between 0 and 1, so it's a vertical shrink by factor of 0.2. If you miss important information because you are playing on your phone, I will remember that. Because I can see the yellow bit. So the next section, we're supposed to use a graphing calculator, but not everybody has it yet. We're going to wait to do the graphing calculator stuff. We're just going to do it by hand. And then I can show you graphing calculator stuff later. So we're just going to do this next section by hand. We have to describe combinations of transformations. So here, what you want to do with question A is you want to first figure out what's the parent function for this one. What family does it belong to? Absolute value. Excellent. So we're going to write down our parent function is f of x equals absolute value of x. And then we're going to look at our parent function, and we're going to look at our new function, and you have to tell me anything that's different. Anything that is different from absolute value of x to negative absolute value x plus 5 minus 3. So anything you notice that's different? What's one thing? Stuart, what's one thing? There's a negative out front. Excellent. So that negative out front, who can tell me in here what that negative out front does to the graph? Brianna? It does. Which way does it reflect it? Yes. Excellent. So it's, sorry, I didn't know that happened. So it's not inside of the absolute value, which are just like parentheses. It's not inside, it's on the outside, so it's got to be vertical. So we're going up and down, that's reflect in the x-axis. Because it's a vertical reflection, it's going up and down, it's going over the x-axis. So that's how we phrase it. Do I have to say all of that? Is that the only thing that's different? No. Ellie, can you tell me something else that's different? Inside of the absolute value, there is a plus 5, right? And does anybody in here know what a plus 5 inside, that's a parenthesis, it's absolute value, but it is a parenthesis. Does anybody know what a plus 5 does if it's on the inside? No, if it's inside, not down.
So translation right?
No, but you're warmer. So if it's inside, this is the trickiest part. If it's inside, it's always opposite of what you think. It is going to go left or right, and when it's inside, since it says plus 5, what are we going to go? Left 5. So you do it the opposite, you just went the wrong way, right? Okay, so we're going to say translate 5 units, which left. So the plus 5 inside means opposite. So we go to the left. That's maybe the trickiest part. Okay? And then what's next? Anything else new? Anything else changed? Anything else different? Anything else different? So what 3? Is it negative 3 or is it subtracting 3? It's subtracting 3. So this subtracting 3, does anybody know what that does? Emma? Translate 3 units down. Perfect. Translate 3 units down. It's not in the parentheses, so it's either up or down. And since it's subtraction, it goes down. question B. F of x equals negative 4x squared. What family does that one belong to? Quadratic family. So we go and we get our parent function. F of x equals x squared. There's our parent function. And then we look at it and we say, Chyla, from our parent function to our new function, is anything different? Okay. Now, Chyla, you actually told me two things. Because the negative sign and the 4 are two different transformations. So the negative sign, who can tell me what the negative sign does? Who can tell me what the negative sign does? Only two people? Carly, can you tell me what the negative sign does? That is perfect. The negative sign, since it's not in parentheses, it's going to reflect in the x-axis. So the negative sign itself is reflect in the x-axis. And so the 4, what operation is between the 4 and the x squared? Jacob, what operation? Between the 4 and the x squared. Add, what? Yes, multiplication. I'm sorry. Operation is like add, subtract, multiply, or divide. What's next when they're next to each other? 4 and then the next. Multiply. So when we're multiplying by a number, what transformation is that? Yeah. Dana? Hi. If we have a 4 in front of it, multiply. Operation, not operation, but transformation is that? You have 3 choices. It's a translation, it's a reflection, or it's stretch or shrink. Got 33.3% chance of getting it right. You gotta guess one. What was the worst thing I'm gonna say? Sorry, you're wrong. But there's a number in front. Wait, we're multiplying it, but which transformation is? I'm looking for words like this. Did that one have a number in front? So it's not reflect and it's not translate. What's the other one? No, look in your notes. What's the one right that we just did before these? Yeah, vertical stretch. I'm kind of deaf though, for real. No joke. We'll talk about it later. So we have a vertical stretch. Plus, you guys are really quiet. By factor. Zena, what factor is it? Yes, of 4. So the negative and then the stretch are two different things. All right? So you're going to finish your worksheet. That's what your assignment is. I'm going to walk around while you're working on it because some people have already done a bunch of it. You were supposed to do like 1 through 11. And I'm going to make sure that you didn't miss any directions and just give you some feedback. And if you have questions, I can answer questions. If a lot of people get done and we still have extra time, then we're going to start learning how to plug stuff into our graphing calculator. Okay? So go ahead and take out your assignment. And I recorded these notes, so if you need to go back and watch any of it, if you zoned out today, it will be posted on YouTube, and you get